So we started by finding the area of a triangle using our SAS. Again, that's side, angle, side in consecutive order. Using our template that they have or gave to us. We did example number 1 by finding the area of the triangle, 24, 55, and 115 degrees to come up with 598. And the main part of the lesson is our law of sines. That was the title, if you didn't notice. And it will be good to have in your notes, so let's go ahead and get it in there. Sine of A over lowercase a is equal to the sine of B over lowercase b is equal to the sine of C over lowercase c. If we take a step back and we look at this, what are a couple of things that you notice? It's okay to state the obvious, that's what we want to do. What's going on here? Tanner, what do you notice?
Sine of the angle over the length of the opposite side is equal.
Yeah, okay, so we start by always working with the sine of the angle and taking it over the opposite side. You know, if we look at angle B, opposite B is lowercase b, opposite angle C is lowercase c. A number over a number is considered to be a ratio, right? Or a fraction, if you will, either one. And now we got equal signs in between. What do we call that when we take a ratio equal to another ratio? Proportion. So really, when you look at the law of sines, it's no more than a glorified proportion, which makes it very, very nice because you all know how to solve proportions. Cross, multiply, and divide. Now, when you work with proportions, how many ratios do you need? 2. Here, they give you 3. And that's because we have 3 angles and 3 sides. So understand, when you do these, you may only have sine of A over A, sine of B over B. You may only have A and C, or you may only have B and C. And that's okay. Right? You only need 2 set equal to each other. When can we use the law of sines? You need to plug this into your notes as well. First one is angle, angle, side. Angle, angle, side could be 30, 45, and 18. 2 adjacent angles, and then there's a side as well. Could also be when you have angle, side, angle. There's an example of angle, side, angle. We call the side the included side between the 2 angles because it's sandwiched between the 2 of them. And the last one is when we have side, side, angle. And in parentheses, it doesn't seem like it's a big deal, but I have 2 possible triangles. And just know, anytime you have side, angle, side, there is the possibility that we could create 2 different triangles off of that given information. And we're actually going to watch a YouTube video here in a little bit that'll better explain what's going on there. An example of a side, side angle if you want. Could be 27, 18, and I don't know, 30 over here. That's an example of side, side angle. As long as we have one of these 3 scenarios, we can use our law of sines. So for example number 2, they want us to find B, lowercase b, so side B, given the information. First thing we need to do is identify what scenario are we working with here. Is this angle, side, angle? Is it side, angle, side? Is it angle, angle, side? Side, side, side? What do we have here? Well, how many angles are given? 2. How many sides? And now I identify the order in which they go in. Angle, angle, side. And that's how we wrote it. Let's go here. Angle, angle, side. Was that one of the scenarios that allowed us to use the law of sines? Yes, it was. If you go back, that was the very first one here. Angle, angle, side. So we can use the law of sines. We want to start out by using the information that they give us. So I'm going to start with angle A, which is 48 degrees. And I'm simply going to put it over the opposite side. 4. Then we set it equal to another ratio. Now which one do you want to use? Well, angle B is given to us, so let's use that one. It's also the side we want to solve for, so perfect. 2 ratios set equal to each other, proportion. All we have to do now is cross multiply and divide. 4 times the sine of 35 is equal to B times the sine of 48. And again, I'm solving for B. So what I have to do is divide both sides by the sine of 48. And while this looks crummy, while it looks messy, just understand the sine of 35 is just a number. And the sine of 48 is just a number. It's an irrational number, probably, but our calculator can handle it. Let's make sure we can do this. 4 times the sine of 35 divided by the sine of 48. Should come up with approximately 3.08. Naturally, if we round to the nearest hundredth, 309. Just do whatever the directions tell you to do. More times than not, they tell you to round to the nearest tenth. Sometimes it's to the nearest hundredth. Everybody good on 309? Law of sines are, I like working with them. Okay, it seems like an advanced property, but at the same time, it's very basic because they're taking concepts that we already know. Cross multiply. And now we get back to the side-side angle scenario. It's a special scenario because what it could potentially do is create 2 different triangles given a couple of pieces of information. And over the years of breaking this thing down, there's one statement that I was able to come up with. You know, the chart is great. You know, it's okay. But at the same time, I wouldn't copy it down. The only thing I would copy down is this statement right here. If the side opposite the given angle is greater than the other side, then there is only one triangle. Once again, if the side opposite the given angle is greater than one other given side, or the other given side, then only one triangle is possible. So in the 2-minute video, they do a really nice job of explaining the two possible triangles that could come from that given scenario, SSA. We'll let her explain and then I'll break it down from there.
Directions for two possible triangles. Draw a point and label it A. Draw a ray extending from point A of considerable but unknown length. Using a protractor, measure a 30-degree angle at point A.
Mr. Dorr, could you please have Caden Resloff come to the office for a message?
Yeah.
Thank you.
Draw a 16-inch line from point A, passing through the 30-degree angle. Label the endpoint B. Using a 10-inch ruler, slide the ruler until it makes a triangle. Label the endpoint C. Continue sliding the 10-inch ruler about point B to see if it will make a triangle.
And this is really the whole thing comes together. Understand the three things that they're given to us. We're given that one of the angles is 30 degrees. And we're given that one of the sides adjacent to it is 16 degrees. Last piece of information that we have is that the opposite side, or the side opposite the 30 degrees, is going to be 10 inches. Okay? Now let's stop for a minute. Let's go back and look at this statement that we had. So this was 16, and this potential side over here is going to be 10. If the side opposite the given angle is greater than the other given side. So let's take a look. The side opposite the given angle. It is what? 10. Is that greater than the other side? No. So therefore, we now have how many different triangles possibly? 2. It's not only one, but now you could be looking at 2. And in fact, you are. And here is how she explains the two different triangles that you can get using those two pieces of information. Y'all okay with the 15 degree or 10-inch side right here? Okay?
Triangle anywhere else. If so, label the point D.
And now what she did is she pivots on point B, and notice we have another intersection point that falls on that ray.
Note that triangles ABC and ABD have two sides and one angle measure the same, but can form two distinct triangles that are not congruent. Directions for two possible triangles that are not congruent.
And there it is. Okay? First one that we're looking at is the overall one. Has all three pieces of information, right? 10, 16, and 30. And then the other one we could be looking at is this one on the inside. Still has all three pieces of information, right? 10, 16, and 30. Right? So that's why we don't really care for the SSA. Just because it can be kind of a nasty problem for us. Possibility of two different triangles. For example, number 3, they want us to find capital B. And if we look at this triangle, what scenario do we have? What 3 letters? Side angle. Anytime you see side angle, you have to be leery of the two possible triangles. I know they give us this diagram, but let's check it. Let's go back to our statement. If the side opposite the given angle is greater than the other given side, then there's only one triangle. Here's the given angle. There's the side opposite. Is it greater than the other one? Yes, it is. Therefore, only one triangle. So we're okay here. Okay? This is the only possible triangle that we can create. What would you like to use to solve for it? Well, probably the only method that we have to solve for it is going to be our law of sines. If we go back, law of sines tell us that yes, we can use SSA. Therefore, the sine of 57 is going to be over what? What's your other ratio going to look like? Sine of angle B. Very good. Over 35. It's nice. It's always just opposites. And you're obviously going to use what's given to you. I would like to finish this problem real quick. If we take 35 times the sine of 57, and then take that number and divide by 63, I'm coming up with 0.4659228, da-da-da-da-da. And again, how do I solve for big B? Inverse. Very good. So you can actually take your calculator, hit the inverse sine button, use your second answer key or your answer key. It'll plug that decimal back in there. And if we round to the nearest 0/10th, 27.8. You can come up with 27.8, you were good.